beginning in Unit 7, we're going to be talking about trigonometric identities and finishing out this particular unit with solving trig equations using these identities. So we have actually already done some of these with the Pythagorean identities. We have sine squared plus cosine squared equals 1, and then the different derivations of it. 1 plus cotangent squared equals cosecant squared. 1 plus tangent squared equals secant squared. We've also talked about the even odd identities. Sine of negative theta equals negative sine theta, and so on. These two sets are odd. This one, even. Reciprocals, we know sine, 1 over cosecant, and vice versa, and so on. And these two, tangent is sine over cosine, and then the reciprocal. So these are some tips to help you simplify using these identities. And they're not hard and fast rules. They are tips. So work on one side of the equation only. If you start messing with both sides, it really screws things up. Okay, you also want to start on the side that's more complicated. So work on one side only. And you want to work on the more complicated side. It's easier to take complicated and make it easy than vice versa. All right, this one is a major tip right here. Change the sine and cosine. Okay, that usually helps out. Look for factoring. Combining, like squaring binomials. That's terrible. Combining fractions. And then you also want to look for places where you can put substitutions, identities as substitutions. All right. Verifying the identities. Tangent theta cosine theta equals sine theta. This one is the more complicated side. All right, so I'm going to turn tangent, cosine, into sine. All right, the rule I want to follow on this one, or the tip I want to follow, is to change sine and cosine. So tangent is theta over cosine theta. Cosine theta, I'm going to leave alone, except make it a fraction by putting it over 1. Okay, and we're going to leave the right side alone. So using our fractions here, when you multiply fractions, you can cross cancel cosine. And then I have sine theta over 1, which is sine theta. So we turned the left side into the right side. Okay, doing the same idea here. We've got cosecant, cosine, tangent equals 1. Obviously, this is the more complicated side. That's where we're going to start. And ideally, because they're all mixed trig functions, you want to change to sine and cosine. Cosecant is 1 over sine. Cosine, I'm not going to change except by putting it over 1. Tangent is sine over cosine. All right, and it should equal 1. Okay, well, I can cross cancel sine to sine, cosine to cosine, and I'm literally left with 1 over 1. So 1 equals 1. We got 1 plus sine times 1 plus sine of negative x. All right, so right here, we're going to use our even odd identities here. Sine of negative x is the same as negative sine x. So I'm going to change this to negative sine x. All right. So obviously this is our more complicated side. That's the side I'm working on, and I want to change it into cosine squared. The next thing is looking in for this. Factoring, squaring binomials, other things like that, the algebra. These are difference of squares. All right, when you multiply conjugates together. Okay, a conjugate, let's find a place for that. Is adding or subtracting. Adding and subtracting. Same two terms. Okay, so in this case, my two terms are 1 and sine. I'm adding them and subtracting them. This is considered a conjugate pair. When I distribute a conjugate pair, I get a difference of squares. Sine squared. Okay, if you're not sure, FOIL it out. I don't know why I just did that. One times 1 times negative sine x, sine x times 1, so you can see those cancel, sine x times negative sine x, so I get my 1 minus sine squared. All right, so let's go back to our identity. Okay, we're looking at this one. Sine squared plus cosine squared equals 1. All right, well, if I take this 1 and subtract sine squared, sine squared equals 1 minus sine squared. So I have an identity here. All of this becomes squared. And so I have successfully changed left side to right side. Okay. We're trying to change this hot mess into sine squared. So we start with that secant squared theta minus 1. So I'm going to go look at my Pythagorean identities, and I see this one. Okay. If I subtract the 1, well, that's what I have here, secant squared minus 1, which means tangent squared equals secant squared minus 1. So I'm going to change secant squared minus 1 into tangent squared. Okay, I'm trying to turn to that left and to the right. It doesn't always work that way, but a lot of times it does. Okay, so tangent squared, we're going to change to sine and cosine. So tangent squared, so this, sine squared over cosine squared. Secant squared is 1 over cosine squared. Okay, when you divide by fractions, which I have, fraction in the numerator, fraction in the denominator. When we divide fractions, you multiply by the reciprocal. Remember, all of this, we're trying to get sine squared. I can cross cancel, cosine squared, and I'm left with sine squared over 1, which is sine squared. Cotangent over cosecant equals cosine. All right. Well, obviously we're changing left side, more complicated, into right side. So I'm going to change cotangent into cosine over sine. And I'm going to change cosecant into 1 over sine. And again, I want it all to equal cosine theta. Okay? So divide by fractions, you multiply by reciprocal. So sine and cosine. You have cosine over 1, which is cosine. Okay, so on this example, they literally just want you to simplify it as far as you can get it. See if you can change it to just one function. So tangent, and in this one it says specifically sine. So tangent cosine, secant is 1 over cosine. And so that can't cancel anything because these two are side by side. So I'm going to multiply the 2, the sine, and the 1. So that's 2 sine. And then across the bottom, cosine squared. All right, so it just wants sine. Well, I have an identity on the other side where I take this one and I subtract the cosine squared. I can see that sine squared equals 1 minus cosine squared. And I did that backwards. I really need to solve for cosine. So if I take sine squared, subtract, then I see that cosine squared equals 1 minus sine squared. God dang it, still did it wrong. Now, all it wanted me to do was write it strictly in terms of sine. So I only want one function there and I want it to be sine, which is what I've done. I can't take this and simplify it any further because I would lose sine. So this is as far as I can go on this function. Okay. I don't usually like this kind of thing because it doesn't feel like it's done, but I got it. I did what the directions asked me and wrote it in sine. All right, so we're going to sub around on this one, and we're going to make it as simple as possible. So I've got cosecant squared minus cotangent squared. Those two are already in an identity, and I see that right here. All right, so I know I can change cosecant squared into 1 plus cotangent squared. So this is 1 plus cotangent squared. And then I already have this. Well, positive cotangent minus cotangent is gone. So this all simplifies down to 1. Factoring. All right. You guys have factored in 1513. You factored quadratic expressions. You found GCFs. You did difference of squares. You factored trinomials. You did a whole bunch. So now we're going to factor that same process and do it with trig functions. So however you learned how to factor, this is what you're going to do here. I find it easier to write these in terms of x. So I'll say let x equal cosine theta. So 2 instead of cosine squared to be x squared. Instead of cosine, x, and then minus 1. I don't care how you learn to factor. Okay, you can do the x method. You can do slide and divide, which I'm still not quite sure how to do. Guess and check. I factor by grouping. So that means I multiply the 2 by the negative 1. I list my factor pairs of negative 2. Find a pair that adds to be 1. Okay, I only have the one factor. It's got to multiply to negative 2, but add to be positive 1. And the only way that happens is if the 1 is negative. So we're going to break this up. Negative 1x, positive 2x. This is still equal to 1x. I have not changed the value of the 1x. I have broken it up. We'll bring everything else down. Group the first 2 and the last 2. GCF of the first group. So we're looking for GCF here. That's x. And we're going to look for a GCF here. There's not one, so you can pull out a positive 1. Common binomial factor. Here and here. So what I have left is an x and a plus 1. All right, so x was cosine, so I want to sub back in the cosine. 2 cosine theta minus 1 times cosine theta plus 1. Okay. Now, you can do this in a couple different ways. If we do it like we did example A here, let's say let x equal cosine. So we've got 4x squared minus 1. This is a difference of squares. So it factors into the conjugate pairs, which are the square roots. So the square root of 4x squared is 2x. Square root of 1 is 1. And the conjugate pairs, we add them. Subtract them. So we get 2 cosine theta plus 1, 2 cosine theta minus 1. If you recognize the difference of squares right away, you do not have to sub in an x. Sometimes that helps. It's kind of up to you. It's what you see when you factor these. Next one, we're verifying the identities. So you want to change the more difficult side into the more into the simpler side. So the left side is more complicated than the right. So I'm not going to rewrite this every time, so it's going to take up a lot of time. But what I am going to do is go ahead and work on this left side. And let's see. On that numerator, if I look at that numerator, I see I have sine theta plus 1. And since I need sine theta plus 1, I'm going to factor it. Sine theta plus 1. Sine theta minus 1 is a difference of squares. And then, let's see, my denominator, it looks like I can factor out a GCF tangent. I don't want the tangent to disappear because I have tangent there. And if I factor that out, I end up with sine theta minus 1, which means I can cancel sine theta minus 1 over tangent theta. I could do a couple different things on this one. I'm going to show you the way that they're looking for. Okay, but then I see a whole nother way I could do this. So what they want you to do is take this equation, or that side, that's the expression, and they want you to multiply by the conjugate. All right, since the left side and the right side are very nearly identical, you kind of pick your poison here. So when I multiply by the conjugate, I have to multiply the top and the bottom by the conjugate of the denominator. All right. And then remember, when you multiply conjugate pairs together, you get a difference of squares. 1 minus sine squared. 1 minus sine squared is cosine squared. Watch your exponents here. This is the one that is cosine squared. All right, so then these two works a little bit like when you actually, it's exactly this way, like when you have x over x squared and use your laws of exponents. I have 1x, it's going to cancel, and this one's going to go down by 1, so we have 1 over x. This one's going to do the same thing. Cosine cancels one of the cosines. So I did change left side into the right side. Okay, there's other ways you can do this. Lumen does ask you to do that kind of more complicated method. It's fine. I see this, and you could cross multiply. We've got difference of squares there, so 1 minus sine squared equals cosine squared. And that is cosine squared. So, again, pick your poison on this one. I think Lumen generally wants you to do this. They want you to recognize multiplying by the conjugate. So as crappy as this looks, okay, your numerator here. This is a difference of squares. Okay, and I know that because I have a subtraction sign in the middle, and these are both squares. So we take the square root, and we add, and subtract. Okay, so luckily that means I can cancel here. And then I'm trying to change into cosine minus sine. Well, this is where your even odd comes in. Sine negative theta is the same as negative sine theta. Odd. Cosine is even, so cosine negative theta is equal to just cosine theta. And then put it in the proper order. Just rearrange it. And there's more than one way to do this problem as well. These are both identities. 1 minus cosine squared is sine squared. 1 plus cotangent squared is cosecant squared. So 1 minus cosine squared is sine squared. 1 plus cotangent squared is cosecant squared. Okay, well, squared is 1 over sine squared. Squared cancels sine squared. And you're left with 1. So we verified the identity.